Okay, welcome back. This is part two of section 1.1. And so we left off here talking about the idea of graphing, right? And I made a couple of graphs here that are on the screen of what maybe that data about the manatees might look like. But I want to just point out that graphing doesn't always mean graphing like you think of when you think of like what do you call this? You would call this a function where you have x's and y's. Graphing could be something like this. And so what we got here is we've got this data set that was collected during World War II. So in World War II, they were collecting data on the bullet holes in planes returning from bombing runs. The question was, or the thing that they were looking at was that they wanted to increase the number of planes that would return from bombing runs because they didn't want the planes getting shot down, which, makes sense. You don't want your planes to get shot down. So they gathered data about the bullet holes. They collected the data about the bullet holes in the planes, and then they graphed it on this kind of overlay of the picture. The challenge being that while you want to armor the planes, you don't want the planes to get too heavy because heavier planes are less removable, they use more fuel, they can carry less bombs, that sort of thing, right? So where do you put the armor? Right? So I've got data and I graphed my data, but my graph of my data is not, this kind of thing with X's and Y's. My graph of my data is literally laying the data on top of a picture of a plane and saying, hey, here's what we got. And so then the question was, where do we put the armor? Well, one question that was raised was, why are there no bullet holes in these places? Right here and right here. Why are there no bullet holes there? Why is there missing data from this? And one of the guys who worked on this, one of the smarter guys who did the statistical analysis of this, said, "Hey, there's this thing called survivorship bias, where we are only seeing the planes that got shot but made it home, and that the missing data in these sections right here means that if a plane got shot there, it didn't return, or meaning it was shot down. So anywhere that I've shaded yellow on this, where there's no data, means that that's where if you get shot, you don't come home." So then what they decided to do is they went through and they added extra armor, extra armor, extra armor, here and here and here and here, and all those places. And essentially they increased the number of planes that would come back from bombing runs, saving lives and effectively ending the war sooner. Right? So graphing data, I know that you've been trained algebraically to see that word and think X, Y. Graphing data just means displaying the data in some meaningful way for the data. So this data, the meaningful way, is to make these sorts of pictures. Right? All right. The last step is when we make our conclusion, where we are trying to decide whether or not our data tells us we should or should not do something. Is it statistically significant? And then if it's statistically significant, is it practically significant? And we'll talk about that here in a second. Statistical significance is the idea that what we saw shouldn't happen by chance, right? So statistically significant, I don't want that. I want a highlighter. Statistically significant is when the likelihood of an event occurring by chance is 5% or less, meaning that chance didn't make this happen, something else did. For example, let's say that you were measuring births at a hospital and you got 98 girls born out of 100 births. We would say that that's statistically significant because the chance of getting 98 girls out of 100 births is extremely rare. It's an extreme outcome that has a probability, a likelihood of occurring of way less than 5%. So we would say, wow, that shouldn't just happen by chance. So that's most likely statistically significant. And I know there's at least one person who is saying, but it could happen. Yes, statistically significant doesn't mean it can't happen by chance. It just means it's extremely unlikely to have happened by chance. The number that we tend to use a lot in stats is that 5% number. So if there's a 5% or less chance of something occurring, we say that there's some significance to that, right? Contrast that with, what if you did a different hospital and there were 52 girls born out of 100 births? Well, we'd look at that and go, yeah, that isn't that unlikely. That's probably actually fairly likely. And since it's fairly likely, we're going to say that that would not be statistically significant. Right? Now, practical significance is a whole other ballgame. Practical significance is saying that, okay, it might be statistically significant, but does that matter? Is it enough of a thing that we should justify its use? Okay? Should the treatment, whatever that treatment might be, right, or the finding, does it make enough of a difference in the world to justify its use? And let's look at an example of that, okay? There was a company out there called ProCare Industries that once was trying to market a product called Gender Choice, and that supposedly if you took this, you could increase the chance of having the baby with the gender that you wanted by using their product, right? Now the FDA, the Food and Drug Administration, stepped in and they said, get out of here with that. That is a gross deception of the consumer. Let's get rid of it. But, okay, when we go back and look at the data, suppose that the product was tested on 10,000 couples. And let's say that of those 10,000 couples, they wanted to have baby girls. And the results, the data that was collected, was there were 5,200 baby girls born out of those 10,000 births. Now, if you run the numbers on it and calculate the probability, the chance of that happening randomly is 0.003%. That's way less than 5%. So what we're saying is that, wow, there's a very small chance that that was just randomly occurring. So then this is statistically significant, right? Now, practically, though, there's only a 52% chance that you're going to have a girl. That's barely above 50%. And depending on how much time or money that you would have to spend for this gender choice treatment, is it worth it? And that's where practical significance comes into play. So the question of, let's say that this thing, whatever this ProCare Industries gender choice was, let's say it costs $5,000. Is it worth $5,000 to increase the chance of a girl birth from 50 to 52%? Is that practically significant? What if it was $10,000? What if it was $20,000? I mean, if it was $5 and you wanted a girl, it might be worth it. Because, yeah, you went from 50 to 52. But if it's 5,000, is it still practically significant? All right. Now, this idea of practical significance, we can't quantify that with a number. It's more of an interpretation of whether it's worth it or not. Right? All right. Now, when you're analyzing data, there are pitfalls. There are potential things that can go wrong, right? One thing that could go wrong is we could have misleading conclusions, right? Where people make statements that they clearly should not make because they have no understanding of these statistics or the terminology or things like that, right? We want to make statements that are clear for people to understand. We don't want to make a conclusion that kind of leaves it vague, right? When you're thinking about this, your final answer, your conclusion that you make, should be something that a person, an average or a below average intelligence person, could read and not make a wrong conclusion from your statements. Right? So you want to make sure you're very clear as to what you say. Okay? Sample data reported instead of measured. Right? This is a problem with data. When collecting data from people, it's better to take the measurement yourself rather than asking the subject to report the data. Right? If you ask someone how tall they are versus actually measuring how tall they are, which do you think is going to give you more accurate data? Okay. If you ask someone how much they weigh versus actually putting them on a scale and finding out how much they weigh, which one do you think is going to give you more accurate data? So if possible, we take the measurements when we're collecting the data rather than just trusting what someone says. When you're performing a survey, loaded questions. Right? If your survey questions are not carefully worded, the results can be misleading just based on how you make the question sound. Right? If you ask someone, when did they stop drinking? Well, you've implied that they drank. And maybe you've implied that they drink too much. And so your wording might load their answer in some way that could make it be misleading. Okay? The order of the questions, the way you present questions can also, oh, wrong one again. The order that you present your questions in can also cause trouble. Okay? Just by how they're asked. Right? What are non-responses? Well, a non-response is when somebody refuses to respond or is unavailable to a survey. How does that affect the data? Okay? All of these things that we're talking about here are potential problems with data that when you're making your decisions, you need to take into consideration. Percentages. When you present results or data as percentages, what does it mean? Can percentages be misleading? Is 100% always a maximum? Right? Recently, a high-level official in our government made the statement that they were going to reduce drug prices by 200%. I think they actually said 200, 300, 500%. That's impossible. If I reduce a price by 100%, I've taken it to zero. If I reduce it by 200%, mathematically, I've taken it into the negative. Like, that doesn't make sense. So clearly, this individual who said this doesn't understand percentages. And so they are citing some sort of data that is very misleading because that reference can't exceed 100% in their statement. Now, could you raise drug prices by 200%? Sure, you could raise the drug price by 200%. If something costs $1 and you raised it by 200%, it would then cost $3. 200% of $1 would be $2. Raising it by that would take $1 plus the $2 to $3. So it could go up, can't go down. Right? So be careful with percentages because how you represent them can matter. Okay? All right. This brings us to the end of section 1.1. Now, I know there was a lot. It was like a fire hose of stuff. But if we go back up to the beginning, the idea of section 1 was just to say, hey, there's lots of things we're going to be doing this semester. There's lots of things we're going to be doing in this course. A lot of it's going to be the ideas, concepts, and terminology. Here are some basics. You may have noticed there was no math, right? There was no calculations we were doing. We were just looking at concepts and ideas, terminology, broad strokes of what we're going to do this semester, right? So when you take a look at the homework, and I think there were 5 questions in section 1.1 homework, it's just going to be those sort of things: broad strokes, definitions, concepts, ideas, processes. I'm going to end the video here. Next one will be for section 1.2, where we'll take a look at types of data, how to collect data, what to do with data. All right. Have a great day.